All right, so we're just going to do a quick refresher on the quadratic formula, just in case you had a little bit of trouble with this one. So again, this formula here is the quadratic formula. Now, this has been figured out by someone else for you, so you don't ever have to derive this formula or come up with it on your own. You can just use it. The letters always stay exactly where you see them. So these two letters will always be B, these will always be A, and this one will always be C, no matter what. Now, where do those letters come from? Well, they come from our standard form equation, ax squared plus bx plus c, meaning whatever letter is in the a spot, so the number in front of x squared always goes in for a. The number in front of the x piece always goes in for b, and the number that doesn't have any letters by it is c. You could be doing this with a formula or with an equation that doesn't have one of those pieces. So if you end up with, like 3x squared plus 7, then you just don't have a b piece to put in, so you'd put in zeros. So the very first thing we said to do was to identify our letters and plug them in. So for example, this equation, 2 would be A, 10 would be B, and -5 would be C. So when I plug those into the equation, I would have -10 plus or minus the square root of 10 squared minus 4 times 2 times -5 over 2 times 2. Once I've plugged everything in, we said step 2 was to simplify the discriminant. Now, there was a reason we wanted to simplify the discriminant first. It tells us some really interesting pieces about this, but it also helps us to put this into a calculator easier. So in case you forgot, the discriminant was everything underneath the square root, so the b squared minus 4ac. What we said in class was that if it ends up being a positive number, you get 2 solutions. So you'll have like x is 7 and x is 10, or whatever. If it ends up as a negative number, you get 2 solutions, but they're imaginary. So it'll be like I times the square root of 10, or 3i, or something like that. But what about if it's 0 exactly? So like this thing automatically works out to 0. That means you have one solution that you're using kind of twice. So simplifying the discriminant not only does it make it easier to plug into a calculator, but it also tells us a little bit about what kind of solutions we can expect from this problem. So in this problem, I'm going to figure out what 10 squared minus 4 times 2 times -5 is first before I deal with anything else. So it's 100 minus -40, which would be 100 plus 40 over 4. Now step 3 is kind of like a half step, I guess, more of a 2.5 than a 3. That's where you're going to simplify your denominator. Okay, once we've gotten this far and we've got everything as simple as we can, that's where we move into making 2 equations. Now, what do I mean by 2 equations? 2 equations comes from this plus or minus. So our 2 equations could be -10 plus the square root of 140 over 4. It could also be -10 minus the square root of 140 over 4. Because those are 2 different unique answers that I would get if I were to type them into a calculator. So -10 plus the square root of 140 over 4, and -10 minus the square root of 140 over 4. Eventually, you will learn how to simplify those a little bit more, but for now, leaving them just like that is just fine. So we're going to try that one more time. So number in front of x squared is a, number in front of x is b, number by itself is c. So when I plug them in, -b would mean that negative of whatever I have. So I don't get rid of this negative sign because there was already one there. It needs to stay no matter what. And then I plug in all the rest of my stuff. And step 2 says to simplify the discriminant. So I'm going to take 144 minus 4 times 36. Well, that's 144 also. So I end up with 144 minus 144. Now, when I have this negative idea here, those both cancel each other out and I'm left with just 12. So my two solutions here are actually 12 over 4, or 3, that we would use twice, because the square root of 0 is just 0, so it's 12 plus 0, 12 minus 0 over 4. So 12 plus 0 over 4 and 12 minus 0 over 4. That's where that comes from. Trying that one more time. So this is not set up for us to solve. Neither one of these are. We'll actually do this one instead. So neither one is really set up for us to solve, meaning there's stuff on both sides of the equal sign. I need everything on the same side as the equal sign. It does not matter which side you choose to move to. I usually try and move it so that the x squared piece stays positive, just because that makes the most sense in my head. So I'm going to add the 3x and the 4 to the other side. Now I've got a, b, and c. So negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. Simplify our discriminant, so 9 minus 16 times 8, 128. Right? So that would be, yeah, that should be right. From here, we would simplify our discriminant, or our denominator also, which gives us 16. So I've got my two equations being negative 3 plus the square root of 128 over 16, and negative 3 minus the square root of 128 over 16. Like I said, eventually we'll learn how to simplify those, but for now, that's as far as you would be expected to go. So in case you're looking for when do I use this, basically anytime a does not equal 1, you're going to want to use this method. Or if you can't find nice factors of your equation. So more often than not, you're going to end up using the quadratic formula for things because it just makes more sense.